Good day, everyone. Welcome to the last topic of the standard normal distribution and the z-table. In our previous topics or discussions, we learned how to graph the values, certain values into the normal curve, and we use the Gaussian function to get the density so that we can graph them into the normal curve. After, we're able to calculate or convert the values in which we denote them using x, no? We were able to convert those x's into their equivalent z-scores. In short, we're able to standardize those values. For this topic, or for our topic for today, we will be discussing the standardized normal distribution using z-table. Here, we'll be able to get the probability for certain z conditions of z to occur or to happen, and that is using the z-table. Now, you have to take note that, again, the area of the curve is equal to 1, now, which is also equivalent to the probability. So the area under the standard normal curve is, again, the probability distribution for z. So if you have here, okay, let me just use a pen. Okay, this shaded portion here, no, say for example, z here, that this point here is z is equal to 0.44. So we will be calculating the area here or the probability of z. Now, the area under the standard normal curve is the probability distribution for the z. For example, the probability of z that is less than or greater than z sub 0. So we will denote this area here to be the probability of z less than or greater than z sub 0 for this case that is 0.44. So we'll have to refer to the um, area here. Okay, now we also have this notation. If we are asked for the probability of z greater than or equal to z sub 0, so that will be if we convert it into a graph. Now, if this is our z sub 0, then we are actually calculating for this area. So greater than, so we'll use the probability of z greater than or equal to, say, negative 1.04. So we are asked to calculate the probability here, or in short, the area of this portion. We also have cases wherein we'll calculate the probability in between z values. So we'll have here, say for example, this is our z sub 0, and this will be our z sub 1. So we'll have to calculate for the probability that z is less than or equal to, greater than rather, or equal to 0.84, but z is less than or equal to 1.28. So how do we do this? So we'll have conditions later or rules later to follow if we want to get the areas of or if we want to solve for these different areas or probability. Okay, now suppose we have these. The question would be, how do we find the area or the probability of the shaded region? So if we are asked to find the area or the probability here, given the previous conditions, so we will make use of our z-table. Here's how a z-table looks like. Okay, and below this video, I will give you two links, for the standard distribution or the z-table, for the standardized normal distribution table. But this is how a z-table looks like. Now you have here values on the first column. Okay, these for the values here are negative 3.8, 3.7, and so on. We also have values on the first row. Now this will be our column headers. You have 0. 0.1, 0.2, 0.3, 0.4, and 0.5, and so on. Okay, the list would go on. Okay, now some tables will only have negative 3.4 as the lowest value and positive 3.4 as the lowest value. There are also some tables which have negative 3.9 as the highest, lowest rather, and positive 3.9 as the lowest. Now, how do we read this one? Okay, let's take for example these. Now, a z-value. So if we are asked find the probability of z less than or equal to 0.5. Now, here, take note that we will use two decimal points, 5 and 0. Now, how do we read this one? Look for, the first step is look at the values in the first column, in the rows under the first column, find for 0.5. So we'll have to separate these two um, decimal places into two. Okay, we'll divide this one into two. Then you will have find 0.5. So we'll have 0.5 here. Then the next one is find 0. Okay, now if we divide this one, this is actually equivalent to 0.5 plus 0.00. Now since we have found 0.5, so we'll need to find 0.00 in the columns, no, in the headers. Now here we have here 0.00. Okay, when we add 0.5 to 0.00, that's 0.50. So the answer will be this one, 0. This will be our answer. Okay, that is 0.6915. So which means that the probability that a z-value or z-score is less than or equal to 0.50 or 0.50 is 0.6915 or 69.15%. Another example is when we are looking for z less than or equal to, let's say, 1.61. So again, we'll have to divide them by 2. So you will have 1.6 plus, that would be, okay, 0.01. So this is this one here, and this is the second group. Then this will be in the first column. No, look into the rows of the first column. Find 1.6. Here we have found 1.6. The next is in the headers. Okay, in the first rows, look for 0.1. So you have 0.1 here. Okay, then in their intersection, okay, if we get the intersection of the two, we'll have here this value. That's 0.9463. So this is how we use the z table. Okay, so we have here some rules on how to use the z table. So to calculate the area to the left of the z value, find the area directly from the z table. So that's the probability of z less than or equal to z sub 0. Next, so here we are actually looking for this one. Okay, if this is our z, which we denote z sub 0, so this shaded portion here is your p z less than z sub 0. So to get its probability, you will just have to get what was stated in the table. However, here, if we want to calculate the area to the right of the z value, we have to find the area in the table and subtract from 1. So say for example, p, okay, since here we are looking for this one, if we have our z here, okay, since this is the one that we're looking for, but those values in the z table were actually referring to this notation. So if the table only refers to this one, then how do we find this? No, the our table can only refers only to the first this one first usage. So that's when z is less than or equal to a z sub zero or a z score. So to get the area to the right of a z value, so we'll have to subtract that area from 1. So what does it mean? We'll get the area here first and subtract it by 1. So we can rewrite this. Okay. P, the probability of z greater than or equal to z sub 0 can actually be rewritten as 1 minus the probability of z, sorry for that, less than or, okay, that's less than or equal to z sub 0. So which means just get the probability of this one. No, will you make use of the table, then subtract that 1 to 1. Okay. An example would be like this. What if we're going to find the probability of z greater than or equal to, say, 1.15? So that would be 1 minus the probability of z less than 1.15. So the reason again, the reason why we rewrite this in this manner, because here in this table, in the z table, this is only referring to, okay, notation, this notation here. So there are only, the area is only calculated based or from the left side of the z. Okay, you take that of the shaded portion. So the calculations of the area is only from the left side of our z. Then we'll have to find the probability of z less than or equal to 1.15. So that's 1.1 and 0.05. Get the intersection. We'll have here 1 minus 0.8749. So we'll get a value of, this is 8. That would be 1, 5, 2, 1. So I think that's the answer. So this will be our answer. Okay. So again, that is when the notation is here greater than or equal to a z score. Now, if we are going to calculate the area in between two z's, okay, so this will be our notation, and to convert it, that would be p z less than or equal to z sub 1 minus, okay, subtract it by which has the lesser value. So that would be z less than or equal to z sub 0. So whichever has a greater value, so that would be on the first term, and those which has a lesser value would be on the second term. So calculate the area between two values of z, find the two areas, and subtract one area from the other. Let's take these examples. Okay, so find the probability of z less than or equal to 1.63. Now I have here again two sites, two websites. One has a better resolution or better, yeah, better images. Okay. The other one is just simple, but I think it's better in terms of the values because there are 5 decimal values in the area, and the z is negative 3.9, so which means it has larger coverage compared with um, the other one. But I will be sending you these two links for your reference. You can download them and use them to solve later problems. But again, no, you will just have to take note that here they will just have the same value. So for example, this negative 3.40 is 0.003 approximately, since we are using 4 decimal places. But if we use 5 decimal places, the 3.4 is 0.0034. So there, it just depends on the number of roundings. But if you would ask me which is better, so I think this would be better. This is better since this table has a greater number of decimal values, decimal places. So the larger is the number of decimal places, the better. Meaning there would be less rounding errors. However, most of the books only presented 4 decimal places. Okay, so let's just make use of these for this time. Okay, now go back. Going back, we'll have to answer what is the probability of z when it is less than or equal to 1.63. So again, divide them by 2. Okay, divide uh, by 2, separate them. So you will have 1.6 and the other one will have 0.03. Okay, we'll have to find 1.6 here, and if we re-add this back, the result will be just the same. So again, 1.63. So using the table, we have positive 1.63. Here, you have 1.6. We just have to look for the 0.03. So the 0.03 is in the fourth column, and that is 0.9484. So which means that the probability here is equal to 0.9484. Okay. Next is um, greater than or equal to negative 1.5. So you have to take note that we will subtract it by from 1. So we'll have to find the probability of z that is less than or equal to negative 0.5. Here, that's 3085. Sorry. Um, 3085. So it will be 0. What's happening? So 0.3085. So what is 1 minus 0.85? This would be 5. That would be 1. This would be 9. And 6. So that is 0.695. So just check if we'll get the same answer. Next, find the probability of a z in between a z value in between negative zero point 0.5 and 1. So again, we'll just have to subtract. So since 1 is greater, so we'll get the probability of 1, subtract it by the probability of z less than or equal to 0 0.5. We already know what is 0 0.5, which is here. That's the probability of negative 0 0.5, that is 0.3085. So we'll just need to look for the probability of 1.0. That's 1.00, positive 1.00. So here, that's 8413. So that would be 0.8413 minus 0.3085. So the result is 13 minus 5 is 8. I just have to carry the 0. So this will be 2. So this one is 3. Kindly check if this is calculations are correct. 3, and this becomes, no, that's still 8, so 5. So that's 0.5328. Okay, then how about this one? Now, this is now a different situation, the reverse of um, the three previous examples. So find a value of z such that p of z greater than or equal to z sub 0 is 0.025. We have to take note that this can be written as p, no, that's 1 rather, 1 minus p probability of z less than or equal to z sub 0, right? Then we'll just have to find, or we'll just have to, since we were given with the area, so we'll just have to subtract this by um, 1 minus 0.025. So what's the result? That's 5, you'll get 7, you'll have 9, so 0.95. So we'll look for a z where the area is 975 or 0.975. So again, in our previous example, we base it from the rows in the first column and the headers. Now, to get the area here, we are given with the areas. We'll just need to find the equivalent z. So again, that's 0.975. Take note that this is the notation. Since the notation is greater than or equal to z sub 0, so that's why we have here 1. Subtract that from 1. Okay, that's 0.975. So look for 975, 975. So here, we have here 975. So that's, get the numbers. Now you have 1.9, add it by here, that's 0.6. So what is our z here? I'll just write here for number 4. So z sub 0 will be of 1.9 and 0.06, which means that is equal to 1.96. We're actually looking for p, where the probability of z greater than or equal to 1.96, and that's equal to 0.025. So our answer is 1.96. Okay, our z sub 0. The other one is much easier since the notation is less than or equal to 1. So find a value, a z, where the area is 0.925. So going back to our table, that's 0.9251. So if I recall it correctly, so we'll have 925, 92. We have 9251, right? So that's 1.4 and 0.04. Now you have to take note that we'll have to round them to the nearest fourth. If we'll use this type of table, so we'll have to round them to the fourth decimal place. So that would be on the 10th thousandths. Okay, we have 1.4 and 0.4. So we have 1.4 plus 0.4, which means our z here, okay, it's not writing. Okay, our z sub 0 is 1 point, and z sub 0 is 1 point, that's 44. 9251. Okay, I'll be rechecking. I forgot even. Okay, 9251. That's 1.4 plus 0.4. That's 1.44. Okay, and lastly, we have this. How to get the probability of this one? We have to find a negative z sub 0 and a positive z sub 0. So it's quite tricky here. Now we'll have a negative value and a positive value. But the what's good here is that if we get the absolute values of these two, they would be just the same, right? So which gives us an idea that in a normal curve, if we recall, in a normal curve, the total area is equal to 1. Now, if z sub 0 here, negative z sub 0 and positive sub 0, as when converted to their absolute value, they will just have the same. That means if this is negative sub 0 and this is positive sub 0, and the area in between is 0.8262, and we know that the total area here is 1.0, right? Which means we can get this area here and this area here by subtracting 1.0 by subtracting 0.8262 from 1.0, right? Then we'll just have to divide them by 2 since both of these sides are equal. So that would mean that the area here, then we can find this area here. Now we can find negative z sub 0, which is in our table, in our z table. So let's solve first for the area. So that's 1.0 minus 0.8262 divide by 2. Now, since we have two sides of equal value, so what will be the answer? This would be 8, 3, 9 minus 2, 7, 9 minus 8 is 1. So that's 0.738 divided by 2. So we'll get 0.0 69. Okay, the 0.0869, which means we'll have to find a z value whose area is 0.0869. So let's go back to our table. So okay, that's 0.0869. 0.08 here, 86, 0.0869. Where is 0.0869? Okay, I'll just check again. 869. 0.0869. Where can we find it? Okay, I'm looking at the wrong area. So 869. 8, yeah. Okay, you have found it here. That's negative 1.36. Okay, negative 1.3 plus 0.06 is negative 1.36, which means our negative z sub 0 is equal to negative 1.36. So since we have these two, when converted to their absolute values, our positive z sub 0 is 136. Now I want you to check if the result is 0.8262. So when you get the area of um, negative 1.36, no, when z is negative 1.36, and also get the probability or area when z is less than or equal to positive 1.36. The result should be 0.8262. Okay. By the way, I have here the answers. Now you have 9.4. Kindly check if those we have the same answer. So that's 9.484, 6915, 5328. Yeah. Okay, we have the same answers. So that's how we use our z table. So now in the next slide, we'll try to get an application or word problem. Okay, now suppose we have an x be a normally distributed random variable with a mean of 10 and a standard deviation of 2. What is the probability that x lies between 11 and 13.6? So we have here given values. So this will be our mean. So denote it as mu. And this is our standard deviation or sigma. Then there are two values. So find the probability that lies between. So in the z distribution curve, we're actually asked the area in between. So our notation would be the probability of z sub 0 less than or equal to z less than or equal to z sub 1. And this will be our x. Let's say this is our x sub 0, which will be converted to z sub 0. And this will be our x sub 1 to be converted to z sub 1. And recall our formula for z, that is x minus mu divided by sigma. Plug in these values or substitute these values, no, you will get c sub 0, that would be x sub 0 minus mu over sigma. So same with z sub 1, that would be z sub 1 is equal to x sub 1 minus mu divided by sigma. So the result will be this. Well, of z sub 0 is 0.5, z sub 1 is 1.80. So the graph would be or would look like this. If this is 0, say this is 1 and this is 2, 0.5 would be somewhere here, 1.8 would be here. So which means this is our c sub 0 and this is our, sorry for that, z sub 1. So we'll have to find this area. And that area is this, the probability of z sub 0 less than or equal to z less than or equal to z sub 1. So we can rewrite that notation to the probability of z less than or equal to z sub 1 minus the probability of z less than or equal to z sub 0. So our z sub 1 is 1.80 and our z sub 0 is 0.50. The probability that z is less than or equal to 1.8 is 0.949641 if we check our z table. And the probability that z is less than or equal to 50 or 0.50 is 0.6915. Subtract the two, you'll get 2.726. So this will be our final answer. So that the probability that the value x lies between 11 and 13.6 is 27.26%. So that is how we solve word problems related to standardized distribution. Okay, now here is a problem which has the answer, and I want you to solve this one. It's quite the same. Now, there are given values here. We have here with a daily, the discharge of suspended solids from a phosphate mine is normally distributed with a daily discharge of 27 milligrams per liter and a standard deviation of 14 milligrams per liter. So what proportion of days will the daily discharge exceed 50 milligrams per liter? Now, when we say daily discharge, we can associate it with the average discharge, right? So this will be our mu, 27 milligrams per liter, and our standard deviation, sigma, is 14 milligrams per liter. Now, since it says that it should exceed, no, what is the probability or what proportion of days will the daily discharge exceed, which means that will be greater than 50 milligrams per liter. So we'll use this notation to denote more than 50 milligrams. So that would be what is the probability. So you have to convert this into its equivalent z value. So you'll have to plug in the z value here later on. No, plug in your calculated z value later on, and the result is 0.0505, or that's 5.05% of all the days. And that's it. So thank you. See you on our next discussion.